So hi and welcome everybody. Welcome back to the course of computer networks. In today's lecture, we are gonna continue talking from where we left off last lecture. Last lecture, I remember we started talking about one of the key functionalities of data link layer, which is flow control. You know, in the previous lectures, early at the beginning of this course and in the middle, we talked about the functionalities of each one of these layers from application to physical layer. One of the key layers here that we are talking about is data link layer. Has many functionalities. We talk about framing, error control, physical addressing, and just last lecture we started talking about flow control, which is a very important mechanism that's done by the data link layer. And today we want to continue talking about this, explain it in detail, understand the protocols that are existing to facilitate the flow control process in computer networks. And after we finish this, we will move on to access control and multi-access protocol. So flow control. What's flow control? It's a speed matching mechanism. What do I mean by speed matching mechanism? Let's say there are three things when you are sending your data. There is the transmitter and the receiver and the link. And each one of these parts has certain speed in processing data, transmitting data, or receiving data, or affording the transmission of data. For example, your receiver has certain speed in accepting the data, has certain speed in buffering the data. Your link has certain maximum capacity that can accept to transfer over. Your transmitter has certain capability of transmitting your data. So to make sure that our data can go through from point A to point B successfully without any distortion or errors between the transmitter and receiver, we have to make sure that whatever the transmitter sends, the receiver can absorb and understand and decode. Other than this, all the packet that we send, it's gonna be waste. It's gonna be dropped out. We don't want this to happen. So what we look after, we look at two things before we start sending our data. We look at how much data our receiver can process, how fast it can process it, and how much is the size of its buffer, and accordingly we adjust the transmission speed at the transmitter so that whatever the transmitter sends, the transmitter gives enough time for the receiver to capture the data packet and decode them successfully without missing any of them. So this is basically what flow control means. So again, flow control coordinates the amount of data that can be sent before receiving an acknowledgement from the receiver. And it's basically, this process is governed by a set of procedures that tells the sender how much data it can transmit before it must wait for an acknowledgement from the receiver. You know, the receiver has a limited speed at which it can process incoming data and a limited amount of memory in which to store incoming data. The receiver must inform the sender before the limits are reached and request that the transmitter send fewer frames or stop temporarily. So this means that the receiver and the transmitter are always talking to each other about their conditions, their situations, their capability of reception and transmission, their link situation and behavior. If my link is good or bad, if there is too much noise or not, if there is interference or not, if the link is congested or not, and if the buffer is full or not. All these factors and other factors as well are taken in the decision of how much data the transmitter should send to the receiver so that the receiver can receive the data successfully. So what are the protocols that are responsible for flow control? We have several protocols, and these protocols are divided into two types. Protocols that are suitable for noiseless channels and protocols for noisy channels. For the noiseless channel, we have the simplest protocol and the stop and wait. For the noisy channels, we have three main protocols. Mainly, they are ARQ protocol. ARQ means automatic repeat request. And this automatic repeat request functionality is associated with stop and wait ARQ, just like the protocol used for noiseless channels, but with ARQ. Go back in ARQ and selective repeat ARQ. So let's here study stop and wait protocol.